All right, this one comes from Digadov9. Whoa! His account's been deleted. Could you perhaps do a deeper dive into inline, cross-inline, and no-inline at some point? Well, today is that point. We're going to look at inline functions and the no-inline and cross-inline modifiers, so let's jump right in. So here I've got a simple script that simulates saving these names to a database. The main function here just sends along these names. The process records function here just calls this save function where we're going to simulate that we're saving it off to a database somewhere. And that call is getting wrapped in this utility function that I just called execute and measure, which is going to run the code and tell us how long it took. Now, one question to ask ourselves here is how many objects are getting created in this process records function? And I think a lot of developers would look at this and just assume that there are no objects getting created in this immediate function. But the truth is that this lambda is actually, when this gets compiled, is actually getting turned into an object. So to show you what I mean, let's decompile the bytecode into Java. That'll give us a little bit better idea what's going on here. So here you can see the new function 0 object is created, and that object is getting passed to the execute and measure function, and it's capturing the record variable up here so that we can use it down here. So what's the problem with this? Well, as I'm sure you know, on the JVM, whenever you create a new object, that object goes on the heap, and allocating room on the heap for that object is a relatively expensive operation. It's not too bad when you're just creating an object here or there, but if we were going to be processing this in a very large loop with thousands and thousands of records, that performance implication could really start adding up. So to help mitigate this, Kotlin offers a function modifier called inline. And when a function is inline, every time you call it in the source code, it's kind of like the contents of that function are just included at the call site when the code is compiled. So in other words, it's kind of like just copying and pasting the contents of that inline function directly into the call site. To demonstrate this, let's turn this execute and measure function into an inline function by adding the inline modifier. With this one change, let's decompile the resulting bytecode again and see what we've got. As we can see, even though there is a function call to execute and measure in our Kotlin code, there's no actual call in the compiled output because the contents of that function were just included in line right here. Now you might have also noticed that the lambda was inlined as well. So in other words, when a function is marked as inline, that inline function is going to be inlined and all of its lambda parameters are also going to be inlined. That's why we no longer need this function 0 object that we had before. Now, if we were to call this execute and measure function in a lot of places throughout our code, it would gradually increase the file size of our compiled bytecode because at every call site, we're duplicating the contents of that inline function. But the advantage here is that we'll probably get better performance out of it. Now, that's not all we get from inline functions. We also get a feature called non-local returns. What's that? Well, normally you can't use a return statement inside of a lambda, or if you do and you wanted to, for example, return from execute and measure, you would have to add a label to it. So to demonstrate this, let's put execute and measure back to a regular non-inline function, and then try to do a return from inside that lambda. When we do this, we get a compiler error saying that the return's not allowed here. And we can add a label to our return so that it'll return from execute and measure. But when we run this, we can see that all it's going to do is skip saving that one record, just the Charlie record. But what if we wanted to abort the entire process records function call? What if we wanted to return from process records? Well, we can't just change the label here to process records. We still get a compiler error. And this would be a non-local return. And we can't do that with a regular function call. But we can do it with an inline function call. So let's put this back to an inline function here. And you can see this removes the compiler error. And when we run this, the process bails once it gets to the letter C. And also this label's not actually needed here anymore, so we'll just remove that. Now, there are some disadvantages to using inline functions. We've got a few trade-offs that we're making here. One is that a lambda parameter can't be nested inside a scope or other context. So let's say that we wanted to, for example, put this code inside of a thread, and we could do that by just creating a thread like this and doing .start here. And you can see we get this compiler error. And even apart from a thread, let's take this back out and just put this inside of a lambda. And you can see we still get a compiler error. So we can't even do that. All we really can do is call it in the immediate scope of this inline function, or we can also call it inside another inline function. So for example, Kotlin's scope functions are all inline. So we can call the block function inside of a run lambda, for example. So again, inside an inline function, we can't normally use a lambda parameter in any nested scope or other context. And the reason for that is that the non-local return could be dangerous. Like here in the thread example again, it wouldn't make sense for code running on another thread to return out of process records. After all, what would happen if by the time this return statement is executed from another thread, what if the process records function had already returned naturally? Or what would happen if multiple records started with C and in these other threads we're trying to return from that process records function simultaneously? So to avoid situations like this, the compiler prevents us from calling that lambda inside another scope. But there are cases where we might want to call the lambda after it's crossed into another scope, and we don't really have a need for a non-local return. For these situations, Kotlin offers a modifier called crossinline. So this modifier goes on a lambda parameter like this. And notice that when we add that modifier, it eliminated the compiler error down here, but it added one up here. So we can either allow non-local returns or our lambda can cross into other scopes, but we can't have both of those things. So when we mark a lambda parameter with crossinline, it's kind of like we're making a promise to the compiler that we are not going to use a non-local return. And with that restriction, it's safe for that lambda to cross into other scopes. So let's remove this non-local return. And finally, let's add some error handling here. So we'll start by creating a third parameter here, which will be the code to run when there's an error. And then let's update our call site. Now that we've got multiple lambda parameters, let's add some labels to these arguments so that we don't get confused about them. And then finally, let's add the try catch down here. And when something goes wrong, we're going to call just an object that's out there called error processor, and we're going to pass it the label and the specific error handler for this block. When we try to do this, we end up with an error. And why is that? Well, remember, when you've got an inline function, each of its lambda parameters is also going to be inlined. And when a lambda parameter is inlined, it's no longer addressable. So remember, we're taking the contents of that function and dumping them out effectively in the compiled code. And so since they're not gathered together in a bucket anymore, there's no way to address it. There's no way to even assign it to a variable or pass it to a function that's not inlined. So in cases like this, you might want one of the lambda parameters to be inlined, but you might not want all of them to be inlined. So what you can do is you can add the noinline modifier to the lambda parameter that you do not want to inline, like this. And with that change, this code compiles just fine. Now we're still going to incur the cost of creating an object for that on error handler, but at least the block parameter is still going to be inlined. With inline, crossinline, and noinline, it's a little easy to get lost in everything. So let's distill what we've gone over. When we inline a function, all of its lambda parameters are also inlined. An inlined lambda parameter can do a non-local return, but it can't cross into a non-inlined nested scope. And you cannot assign it to a variable or pass it to a non-inlined function. If we change a lambda parameter to crossinline, it is still inlined in the compiled output. It is not able to do a non-local return, but it can cross into a non-inlined nested scope. And just like with a regular inlined Lambda parameter, you can't assign it to a variable or pass it to a non-inlined function. And finally, we can mark a Lambda parameter as noinline, in which case its contents will not be inlined. Since it's not inlined, it cannot do a non-local return. However, it can cross into non-inlined nested scopes, and it can be assigned to a variable or be passed to a non-inlined function. So there you go. Inline functions can be a great way to reduce performance overhead in certain situations. Just keep in mind that by replicating the contents of the inline function throughout your code base, it is possible to increase the file size of your compiled output. And also, anytime it comes to performance, things are not always quite as simple as they seem. So a lot of factors come into play, especially when you're running on the JVM, which can introduce its own runtime optimizations. So when in doubt, use JMH to run some performance benchmarks on your code to really understand how the changes you're making to your code are affecting performance. And by the way, be sure to sign up for my brand new email newsletter. You can do that at newsletter.typealias.com. And that way you'll be among the first to know about any new videos, articles, or projects that I've got up my sleeve. And finally, reach out in the comments or on social media with any thoughts, ideas, or questions you have, or just to say hello. Thanks again to Digadov for requesting this video, and thanks to you for watching it. I'll see you next time.
You've read the chapters online, and now I'm proud to present the Lean Puff edition of Kotlin, an illustrated guide. Take the book offline with you, mark it up in your favorite PDF software, and get early access to new chapters as they're written. You can pick up your copy today. Just go to book.typealias.com.